morning, students. So we will continue from where we left in last class. So today's topic is data types in Java. So in last session, we have understood how to run a Java program and how to install JDK and what is the role of a compiler. And we have started one basic program also. And we have seen uh, the whole anatomy of the minimal Java program. So now I'm starting the most important topic in language, Java language itself, and that thing is Java data types. We have all of us, we already know what is a data type because we have gone through C and C++, and we have also gone through Python. All of us have taken a course in C, C++, and Python. So we have the basic idea of the data types. But I'm starting from the Java perspective. So if you like data types, if you like to define a data types basically used to specify the kind of data. The kind of data, if you carefully see here, the kind of data we are talking about, kind of a data. And one another thing that we are mentioning here is a variable. So we are talking about a variable, let's say X, and what type of a data it can hold or it can possess. It is a data type. So it can possess maybe a number, or it can possess a character also. So character in Java is identified by this literal single quote. So it can possess a character like J, or it can be a Boolean value also. So why I'm writing X again and again, because this is a most common variable. So variable can hold what type of a data. This is a data type. So it can be like true or false also. True or false also. True means obviously it is one we are talking about, and false means what? It is zero. So one example it is given here, integer age. Integer age. So what is a variable here? Age is a variable because it is going to change the value throughout the program, and the type of a age is what? Integer. And what is the value that age is storing? The value is what? 25. So there are three things in that. One thing is called a value, which is 25, and this is what? A variable. And this third thing is our topic is what? A data type. Data type. So three things you have to clearly understand when you are writing this kind of expression. One is a variable, one is a data type. That is what type of a data it is holding. So if I write like this, character, and I write like this, ch is equal to j. Yes. So in this case, j is a value, ch is a variable name, and character is a data type. I hope okay, it is making sense. Now, uh, very important point, and this you have to remember for your life long. Okay, so you can't miss this thing. There are two kinds of a data types in Java. First one is primitive, primitive, and those primitive data types are provided by Java. And when I'm saying it is provided by Java, so there are two things. I'm talking about JDK, Java Development Kit, and I'm also talking about Java compiler, and I'm also talking about JVM. So together I'm saying that this thing is provided by Java compiler and JVM. What does it mean? So meaning is that they are primitive, they are inbuilt, they are inbuilt. So Java compiler directly can understand these kind of primitive data types because they are already there. They are a part of a compiler, and they will run in JVM. Directly they will run in JVM. Then second is what? Reference type. Reference type. So one is a primitive which is inbuilt, and second is what? Reference type. For reference type, you may note it down one more a name, and that is called user defined data type. So that way you will understand more. Reference types are user defined data types, so they are not generally given by Java compiler and JVM, but rather we are defining it. We as a user, defining it, and we are storing in libraries. So one of the example of reference, very special reference data type is what? Is string. Another very special data type of a user defined is what? Arrays. So these two are reference data types. Moreover, there are many other kinds of reference data types that we have to learn throughout our course. So let me give you one more time. There are two kinds. One is primitive, which is called inbuilt, given by JVM, Java C, and JDK. Together, it will be given by primarily given by what? Java itself. Then the reference types, they are like user defined. So we are defining those data types and we are using them. So the way they organize are slightly different. So if you remember, very important point, I'm talking about a JVM architecture that we discussed in last session. So I said two kinds of memories are there. You have to note it down. One is stack and another is what? If you remember, another is what? Heap. So two kinds of memory are there in JVM. There are other kinds of memory also, but very important to note it down. One is a stack and another is heap. Why I'm discussing here, I told you at that time also, please make a memory of this architecture in your mind. So primitive data types, they are always stored in stack. They are always stored on stack. And reference data types, they are going to stored on heap. That's the main difference. They are user defined, they are reference type, they are going to store on a heap, and it is going to store, I mean, a primitive data type, it is going to store on a stack. That's two difference. You have to note it down. Now again, this is the whole picture of all the data types in a Java, and this is like a roadmap of Java also. I said it, one is primitive and another is non-primitive. We'll come to this non-primitive later. And inside this primitive, if you want to classify, one is Boolean. So Boolean is only one, which is Boolean itself. And it can take, for example, X can take either true, which is one. The value is not one. We write it, true only. So you can write it true or you can write it false. So it is a Boolean. Now we are coming to a numeric. Yes, numeric. Again, there are two categories. Inside this numeric, we have character. Some of you may disagree at this point also, but it is correct. Don't worry about that. We'll come to understand. Then numeric, one is integral. And inside this integral, we have integer data type and we have floating data type. Floating data type. So inside integer, we have byte, short, integer, and long. Yes, and inside floating point, we have float and we have double. Forget about these non-primitive data type because they are user-defined data type. So we are only here at this area. So if somebody can count it, how many actual data types are given by a Java compiler or JVM from day one itself is number one this, number two this, number three this, then 4, 5, 6, 7, and 8. So only 8 primitive data types are given by Java, and this will cover a lot. This will cover a lot. So we are going to start one by one, and our starting point is the easiest one that we will pick up, and from this we will try to understand the anatomy of data types, and we'll see the insights of a data types also. So we'll start with integer, and in integer we have to go through all these: byte, short, integer, and long. Then we'll come to the other data types also. So I hope you have understood the data types. There are two ways: primitive and reference type. Yes, and one thing I said, it is holding any kind of a data. Okay, so for example, variable name is there X, and we are holding some kind. For example, maybe integer or maybe character. That's the thing that we are holding. This is one way to understand a data type. Another way to understand is it is like a container because it is holding something. So it is like a container, and containers can be of different shapes and different size. So size is very important and shape is also very important. Shape in a sense, what type? So maybe it is integer or maybe it is character. But what about the size? Okay, yeah, obviously we are talking about integer values. So what is the maximum value that we can store? What is the minimum value that we can store? How many distinct values we can store? This is defined by the containers. Okay, container size. This is defined by the container size. So everything is there in these data type. Let's continue this. And as I said that okay, we are going to study first the integer data types. Integer data types. So it's like a container, as I said. So here, if you see, byte is the shortest kind of a integer data type. Let me say it once again. Byte is the shortest kind of a integer data type, and short is just double in size of a what byte, and they are like containers and they are holding some values, and integer is just double of what short. So it is 8 bits, that means 1 byte. It is 16 bit, that means 2 bytes. Integer is a 32 bit, that means it is what 4 bytes. And we have one thing called long also. This long is just the double of integer, so it is 16 4 bits, that means what it is 8 bit long. But the point is, all these four data types are of integer size. So as I have said, it is 8 bit. And one more thing I'm writing here is a signed integer, sign integer. So slowly, we are introducing things. Sign integer. What is the meaning of sign integer? The meaning is that it can possess a negative as well as it can possess a positive values. Now, when you are saying a sign integer, it is putting a lot of stress while we calculating a range and while we calculating a memory representation, because we are taking the sign negative values also and we are taking the positive values also. So unlike other languages, Java is providing four kinds of a integer data type, and all those are signed a data type or signed integer. Signed integer, I mean, they can have a negative value and they can have a positive value. I know one language which is C sharp, so I'm considering the other languages also. In C sharp, it was developed after the development of Java. So many things, many concept, I would say, it has taken from Java straight away, but it has given some more extra things also apart from Java features. So one of the feature is that it provides unsigned integer also. Unsigned integer means it can have only positive values, or signed integer may have a negative values also. Like C and C++ also, they can have unsigned integers also. I hope it is making sense. So now I am coming to the problem solving approach, and with this question, I hope most of the things that we have studied till now will clear. So we have a very simple question, and we are just considering byte data type, byte data type. And in Java, it is well defined that it is 8-bit and it is sign. What is the meaning of sign? Negative as well as positive values. Positive values. We have to answer the following questions logically. What is the maximum value that can be stored in a byte variable? What is the minimum value that can be stored in a byte variable? How many distinct values can be represented by a byte variable? So let's start with, and if you recall the memory structure is like this. We have memory, it is nothing but a collection of bytes. So, and one byte contains how many bits? 8 bits. So 1 2 3 4 5 6 7 and 8. So if you are talking about one byte, so how many bits are there? 8 bits are there. 1 2 3 4 5 6 7 8. This is a size of what? One byte. That's why it is known as byte data type. And how many bits are there? How many bits are there? These are 8 bits. So how many possible distinct values we can store in that? And if you remember from the memory class, how can we find out? We can find out just by putting, if you try to find out the range, and range is nothing but distinct values. Distinct values. So how we can find out the distinct value? It is nothing but 2 to the power 8, because 8 bits we are taken. And if you are calculating 2 to the power 8, it will come out, yes, 256. 256. So how many distinct values it can store? 256 distinct values it can store. But in 256 we have negative also, and we have positive also. So it's tricky. So how can we store a negative values, and how can we store a positive values? For that, what we would do is we would divide 256 by 2, because half of the values, or half of the distinct values, we are giving to negative, and half of the values we are giving to positive. So if you divide by 256 by 2, that will come out 128. 128. So negative side we can have 128 values, and positive side we can have again 128 values. But remember one thing, so if you are starting from 128 minus, yes, 128 minus, then 127, and then 126, all the way you're coming to 0, then you're starting 1, then you're starting 2, and you are going up to what, 128? No, you are not going up to 128, because one distinct value that we have taken is 0. So we would go up to 127. That's the way. If you count it, there are 256 distinct values. You can try by small numbers, otherwise it's not a long list. You can count it. Even you can make a program and you can count this thing. Hope I'm making sense here. So minimum value that it can store is what, 128. Maximum value it can store what, 127. And distinct values it can store is, I mean different values it can store is 256. So if you go back here, answer is for this maximum value is 127, minimum value is 128, and distinct values is 256. Yes, if I'm not making any mistake here. Yes, that's it. That's the correct answer for that. Then if you have find out all the way the values of byte, then obviously you can find out the same thing for short also. So for short, if you can see here, uh, because what we would do here, we would, let me write it itself rather than explaining. Okay, so for short students, it would be what, 2 to the power 16. These are the distinct values. And maximum value is what? Maximum value is 2 to the power uh, yes, 16 divided by 2 minus 1, making it slightly a complex expression, but hope all of you are from mathematics, so you will understand that. 2 to the power 16 divided by 2 minus 1, and this value will come out 3267. What would be the minimum value? Obviously 2 to the power 16 divided by 2, and you will put up a minus. So here the value would come what? Minus 32768. Similarly, for integer, here the range is becoming what? Because we are using 32 bits. So the range will become what? 2 to the power 32. This is the range. That means these are the distinct values. But we are taking what? Negative values also. So for negative, what we would do? We would divide by 2. That's it. 2 to the power 31 it will come. And this is 2 to the power 31. 2 to the power 31 minus 1, this value would come. And we have one more data type, and that data type is what? Long. And long is for storing the long integers. And these integers are of how much length? 64 bits. So obviously this is too large string, and 2 to the power 64, you can find out if you compute the value divided by 2, that means 2 to the power 63, this value will come. Yes, one more thing I'm taking here, and I request you, I request all of you to please pay a special attention, because we are going in very details. Now we are trying to understand one more very interesting thing, and one more very, a bit level thing. And that thing is how negative values are stored in uh, these things. For example, what I'm trying to say is that, let's say okay, there is a data type which is 4 bits only, 4 bits. So how many possible values are there? 2 to the power 4, which is nothing but 16. So if you are trying to convert into a binary values, you can easily convert it. You will start from 0, 0, 0, then you would have 0, 0, 1, then you would have 0, 0, 1, 0. Likewise, you can go up to 1, 1, 1, and 1. That would be 16. Yes. With in this case, all the values are positive only. All the values are positive only. What about the negative values? Negative values. Remember, we are storing negative values also. So in case of a byte, minus 128, minus 127, and then up to minus 1 also. So these negative values are stored, but memory can only understand zeros and ones. That means we required a binary for that. So the question is, given the byte data type in Java is an 8-bit sign integer, how are the negative numbers are stored in memory for byte data type? So these are the negative numbers that are there in memory. Then what is the binary representation of minus 128? Because negative thing we don't have in a memory. We just have 0 and we just have 1. So then how we are storing the negative numbers, that we need to understand. And that is very helpful when we are going actually in very low level programming. Low level programming in a sense when there is a buffer overflow attack. Yes, I don't know how many of you have heard about this thing called buffer overflow or integer overflow or integer buffer overflow. And this is causing, believe me or not, a lot of problem in programming. Even a simple kind of a script which can create a problem if you don't understand this memory representation, because it is very important. So let's start this. So the first answer is quite easy. We have one method called 2s complement. 2s complement, and this thing you have gone through in a computer architecture class also, and digital logic design class also, and even uh, I think it is there in computer network also. That's a very basic fundamental thing. It's not a rocket science. Simple 3-step algorithm is there. So for storing a negative numbers, what we use is 2s complement representation. Let me try to prove what I'm saying is, like for example, if you are trying to find out the memory representation of what? Minus 28. So you have to store in a 2s complement way. 2s complement way. So the steps are very simple. I would write it in a stepwise manner, and all of you please note it down and pay attention here. What is the step 1? Find the binary representation. Okay, find, let me write it itself, binary representation of positive number. Okay, then the second step is this. Second step is that after finding the, this is very easy, invert all the bits. I'm writing in my own words, invert all bits. This would be the second steps. Okay, what is the meaning of invert? Invert means 0 will become what? 1, and 1 will become what? 0. That is the meaning of invert. Then step 3 is what? Step 3 is what? What is the step 3? Yeah, if I'm recalling it correct, add 1 to the result. Add 1 to the result. So 3 steps process is there for computing the 2s complement of any negative number. So we are taking the example of what? Minus 128. So binary representation of positive number. We have 128. So first step is we have to write a binary representation of positive 128, and that is very simple. 1 0 0, and again 4 times 0. 4 times 0. This is first step. Step number 1. Then step number 2 is what? Understood or not? 128 is very easy to remember in binary form. So for 128, this is the binary representation. Then invert all the bits. So what will happen? 1 will become what? 0. and all the bits, rest of the bits will become what? 1. So quickly I'm writing 1, 1 and 1. Yes, this is the step 2, invert. Then what is the step 3? Step 3 is we have to add 1, 1 to this number. So uh, if you add, I'm writing once again 1, 1, 1, again 1, 1, 1. Hope I'm not making any mistake here. Then plus 1 I'm doing here. So once you do the plus, will become what? Will become what? 1,
Yes,
0,
one
0, and
triple
then
zero and then four times.
yes, very nice. It will become what? So that's the representation. Let me check it. I think I have done this before. So yes, if I'm not again making any mistake for minus 128, so this is the correct answer. Yes, steps are also fine. These are the general generic step I was recalling from my memory. So first step is done, then second step is done, and then third step is done. And this is how we are representing uh, um, one minus 128, minus 128 in memory. So minus 128 in memory will look like this. I've taken a one representation also. For example, if you are here, so positive numbers are not a problem, kids. Positive numbers are problem. They are following a general and the generic convention. So 1 is obviously this is 1. And for 2, it is a 2, no problem. Positive numbers are no change in there in that. So 127, this is 127. And then when you are coming to uh, the negative numbers, obviously some slots are remaining because we are taking only 0 to 127. So in binary, all the slots are remaining. All the slots, I mean, all the free slots of the memory are remaining. So those things we can use it with the 2s complement method, and that they can be represented by that they can be represented for a memory. So this is minus 128, this is minus 127, and this is minus 126. I would request you to at least try this once, and if you find any difficulty, you can back to me once again. Absolutely no problem, and you can check it by your program also. So what we have done till now, students, we have seen uh, what we have seen is one is integer data type, especially we have seen 1 byte, and the name itself, it is suggesting it is 1 byte. That means how many bits are there? 8 bits are there. So we have seen all the things in that.
Yes, sir.
So let's see a demonstration of what we have learned till now. So we have learned only a one data type, that is byte, and byte is a keyword in Java. So I'm making byte b1, and I'm trying to store, let's say, a negative value. So minus 1. Okay, and just for your information, what I would do is I would print out also. I would use a shortcut, and what I would do, I would just print the value. What I'm trying to prove here, let's see carefully. When I'm storing minus 1, it is causing no problem. And when I'm storing 128, again, it is giving me no problem. It is giving me no error. But as soon as I increase the range, yes, so I'm increasing from minus 128 to 129. Now, straight away, this is the beauty of Visual Studio Code at design time, or you can say at this writing time, it will show the error, and it is showing that this mismatch cannot convert from integer to byte. So uh, it's the Visual Studio Code, it is taking this value as an integer, and it is saying that it cannot be converted into byte. Now I'm taking a positive values. So positive values, I don't use a positive sign, rather I will write it simply. So 1 is okay, even 100 is okay, but when I write 127, still it is okay. But when I write 128, so 128 is just I have crossed one limit. So it is again will show the same thing, because 128 cannot store in byte data type. So minimum value, maximum value, and the range. I hope you understand that. Similarly, if you want to write, let me put it 127 so that it won't show any error. For short, so I'll define one variable short. So there is a keyword short s1 I'm taking here, and the minimum value, if I remember, 3 32768 minus 32768, and it is not giving me an error. That means I am right. But when I type 69, so now it is not taking because it is outside the range of a short. And when I'm taking 6 8 and I'm removing the negative sign, so it starts giving me an error because again I have just crossed the range. So if I'm now putting 7, so it is not giving me an error. So that's the beauty of Visual Studio Code. You can do the experiments straight away here only. Now I have another thing to explain, and that thing I hope all of you will take an interest in that, and all of you will listen carefully. And this is like a first question in your interview also. So I'm defining two variable, uh, byte B2, and here I'm putting just one so that the range you can understand. And here I'm putting 5. Yes, 5. And I'm taking one more variable, byte B3, and this B3, I'm writing an expression. An expression is B1 plus 1 only. So you know that, students, you know that B1 is 1 and I'm just taking 1, but still it is giving me an error. So if you try to run this program and you try to print B3, it is not going to give you a B3. Straight away it is stopping you and it is giving you an error. And the error is that type mismatch cannot convert from integer to byte Java. What does it mean here? Because I'm taking 1 here and I'm also taking 1 here, and 1 is within the range of a byte, then still it is giving me an error. And this is like a favorite question of the data types. Why this value gives an error in a Java? There are two answers for that, students. And the first answer is that this value 1 itself, it's a constant. You note it down. This value is constant, and somewhere in JVM, this constant is stored in memory. What I'm trying to say is in JVM, let me write it, in JVM, somewhere, I mean in some memory location, this one is going to stored. One is going to stored. And that thing is integer itself. So JVM is storing this constant value in integer data type. That's why it is giving us an error, because integer plus byte will become what? Integer. Yes, and this integer cannot be stored in byte p3. All of you, please, this expression is very confusing because according to the range, we don't have any problem, but still it is giving a problem. The reason is that this is a constant. This is a constant literal, and in JVM, it is stored as integer. Okay, so I hope you have understood. So now I have another problem in this. Now if I write b2, so now what is the problem? I understood that 1 is stored in JVM as integer. So integer plus byte will become what? Integer, and that thing cannot be stored in b3. I understood. Now I know this is a byte, this is a byte, and they are within the range. They are within the range. 1 plus 5 is 6 only, and this is in the range. But still it is giving me an error. Why this is giving me an error now? Again, it is saying the same thing. The mismatch cannot convert from integer to byte Java. The answer for this is, students, this thing is called, there is a technical term for that, and that thing is called type uh, promotion. Type promotion in arithmetic. So you are doing a plus operation. This is called arithmetic. Again, Java has one facility. So when you are doing a arithmetic operations like plus, minus, so what Java will do automatically, Java will convert these smaller data types into integer, because they have to maintain some kind of data type in their temporary memory. So Java has converted this byte into what? Temporary integer, and again this byte into uh, uh, you know uh, temporary integer, and this whole expression will become what? Integer. So if you're trying to store this integer into byte 3, obviously it is not going to store. The best part is that view problem, we have understood the problem. Quick fix, we have some solution. So it is saying that, okay, you tell Java that, yeah, still it is a byte only, so I'm taking a guarantee, so you do a casting for me. So I would add on this, and this way the problem is going to be resolved in that. And if you run this now, B3 is giving answer 6. So all the calculations plus minus, they are performing without any problem. Now, uh, one thing I would show here just for integer. So let me write it short also. Short S1 or short S, I'm taking only one variable. So the maximum value is, let's say this is the value that we can take. Yeah, I'm increasing the value. So this value I can take in short. One interesting thing I would show you. Then for integer I can take a value, let's say one more bigger value, 5, 6, 7, 8, any random value I can take, and as soon as I increase the range, it will start giving me an array. So this random value I can store in integer. But for a long, and if you count the length of all the integers in long, you can count it. The maximum length is what? 19. So you can store a 19, maximum 19 integers in that. So I'm defining one long L, and I'm taking these numbers 5, 6, 6, 6, 7, 8, 8, 8, 8, 9. So it is still 19 is not there, but still it is giving me an app. Okay, now please stop here and think about that. It is within the range, and I have defined a long L, but still it is giving me an error. The literal is type integer is out of range. Bro, I have defined this thing as a long, and why you are taking this as an integer? Why you are taking this as an integer? Yes, Java is considering by default everything as integer, every constant value as an integer. So no quick fix is available. So the quick fix is very simple. We have to tell that Java, please take this value as long. And to tell, how to tell? By using this literal called L. So as soon as you put L, Java will come to know, Java compiler will come to know, yeah, this is an integer. This is an integer. Sorry, this is not an integer. This is long. So for integer, maximum range is out. So I have taken a long, and long I have to tell Java, okay, this is along by this literal L. And now you can print this value also, absolutely no problem. L is there. You can print this value. Okay, now we are coming to the conversion part. So one conversion is what? Implicit type conversion, which can be done automatically by Java. And one thing is called explicit type conversion, which we have to specify. And what is an implicit conversion? The name itself, it is saying that it is done automatically. And when it is done automatically, when you are converting a type from a small to large, small to large, then it is implicit. Okay, so this here, when you are pouring any liquid from a small glass to a larger glass, we don't have any kind of a risk, because the liquid is not going outside. Yes, we don't have any kind of a risk. So it is implicit. Implicit is from small to large. On the other hand, if you know that, okay, your large glass is containing only this much of a liquid, and you have a small container also, so you can convert it, no problem. but there is a chance. There is a chance if the liquid is up to this place. So when you are trying to convert it into that, it may cause a overflow effect also, and that thing will become what? Overflow. Overflow. And from where the term is coming, overflow. And this overflow, sometimes it becomes very dangerous. So explicit type conversion is, we are telling explicitly Java, to Java, that please, from long, I don't mean data type, from long to short size data type you can convert, and we are telling that. So implicit is what? If you are converting from, now I'm telling the data type long to integer, no problem. From integer to short, no problem. And from short to byte, no problem. But if you are taking a reverse, then this is called explicit, and we have to tell. And this explicit, lot of chances for what? Lot of chances of spillover, lot of chances of buffer overflow, lot of funny effects also you would see in that. And to explain this my point, I have one very simple question, and you have to do with the program only. The program is like this: you have you have two bytes. So byte b1 is equal to what? 100. Okay, 100. So it's no problem. Then byte b2, this is equal to 50. Absolutely no problem. Now you are defining byte b3, and you are telling that, okay, it is b1 plus b2. Yes, b1 plus b2. So Java will tell you, okay, please, this is expression, will promote it to an integer, so convert it into what? Byte. So what we would write is, instead of this, we would write byte, and we would write what? b1 plus b2. But remember one thing in that: what is b1? 100. What is b2? Is 50. So it is becoming 150. Now when it is becoming 150, and our range is positive 127. So how this value is going to stored in single byte, and what would be the final result? What would be the final result? Let me run this. So what is the program that we are writing here? B1 is equal to what? What we have taken as 100.
100.
Okay, and that, yes, and B2 we have taken as
50.
50, and then we have defined another variable, right? B3, which is equal to B1 plus B2. Now it is giving an error. Okay, and quick fix, I can use this at cast. Now it is giving no error. But when you are trying to print this B3, obviously 150 is not coming. So what else is coming? Because 150 is going out of the range. So if you are trying to run this program, obviously I'm 100% sure 150 is not coming. Then what is coming? The final value is what? Minus 106. So is it random value, or is it some garbage value, or is it some scientific value? Scientific value, again, for overflow, we can observe some algorithmic or scientific pattern in that. The answer is, it's not a random value, it's not a garbage value, it is a value which we can predict easily. How can we predict this value easily? Let me tell you. So let me give you a description for this. And the description is pretty simple. Pretty simple. The binary representation of 150 is what? This value. 150 I'm talking about. 150. This value is 8-bit. Still, it is in the range of 8-bit only. You can count it the bits 1, 2, 3, 4, 5, 6, 7, 8. Only 8 bits are there. However, in byte data type, this represents what? Minus 106. How this represents a minus 106? Because for some other values, for some negative values, we are storing in 2s complement. And to prove my point, we can take a 2s complement of this also. What is the step of 2s complement? Just remove this negative signs, make it positive. So we made it positive. And now convert it into a binary thing. So for 106, this is the binary value. Now invert all the bits. Second step is what? Invert all the bits. So I have inverted all the bits. 0 become 1 and 1 become 0. Add 1. So we have added 1 onto that. Find out the actual value. So actual value is what? 1 0 0 1 0 1 1 0. And if you see that this is in positive numbers, this is representing what? 150. So 150 it has done. It is calculated the a binary number. Binary number is this, and the compiler stored this binary number into 1 byte. No problem. I will store in a binary number. But when I'm retrieving this value, because we are in a byte data type, so byte data type, it is saying that okay, this is representing minus 106, and it is not representing what? 150, it is representing 106. So that's why it is showing what? 106. This is one overflow effect that you can see here. There are more overflow effects on that, and some times it causes a hacking also, because if we can predict the overflow effect, so we can hack into the system, and we can hack into the applications, and the application will reveal some of the important information.